Welcome to part 2 of our Quickstart series on deploying CAS for GCP. In this video, we'll go over how to deploy CAS on GCP using our Quickstart script, which is located in our GitHub Cloud Deployment Scripts repository. Our goal in this video is to set everything up on GCP so that we have a copy of Cloud Access software ready to be used for our next part. In the next part, part 3 of this Quickstart series, we'll then connect to our workstations. In the last video, we briefly provided an introduction of CAS. We then logged into our GCP account and created our GCP project. We also discussed the requirements and the deployment architecture. So back over on our README page, we'll go back to our GCP README page and click on this blue button that says Open in Google Cloud Shell. Let's go ahead and open this in a new tab. Since we've already logged into our GCP account and we've also set up our GCP project, we should be prompted to say that we're about to clone the Cloud Deployment Scripts repo. Let's check off Trust repo and click on Confirm. It will just take a quick second to get our Cloud Shell virtual machine up and running. On the left side of the screen here, once it's done, we can see that our command line interface is on the left side, and this is our Cloud Shell environment. All our commands that we'll be executing will be shown on this screen here as we go through the rest of this tutorial. Here we can see that we've successfully cloned our repository. On the right of the screen, we'll find a tutorial tab with usage instructions as well as the code snippets, which will make our deployment experience as easy as possible. It's also there for future deployment reference so that the next time you want to rerun the deployment, you can simply follow these steps. When we run the script, it'll begin to prompt us to enter a few parameters, which we will go over together in this video. The Python script that we'll be running is a wrapper script that sets up the environment required for running our Terraform scripts. The Python script will then use Terraform to create the actual GCP infrastructure, such as the networking and the compute resources. Let's go ahead and begin. So here we've already clicked Start, and that will take us to the next tab of the tutorial. And the first step to create our deployment is to select our GCP project that we want to create our deployment in. We can simply click on this code icon here, which will actually copy and paste the code snippet right into our command line. Be sure to change the project ID to the one that we've created from part 1 of this tutorial series. I will go ahead and find mine back over in the GCP console. Once we have it copied, we can come back to our Cloud Shell and paste that in, and we'll press Enter. It will then begin to prompt us to authorize our credentials, and we'll click on Authorize. Now that we've set our GCP project, we can execute our Python script. We'll use the next command here, which will first change the directory to where the script is located. Then the command will execute it. The script will now run and prepare all the necessary steps to create our deployment. Once all the dependencies are installed, such as our Python packages and Terraform, the script will begin enabling the required Google APIs. Please note this process may take up to 5 minutes, so we'll come back when it's complete. Once that's complete, the script will now prompt us to enter a few parameters. The first is a prefix. The prefix is used to ensure the resources we're deploying to GCP is unique within the project. Here, the default value is quick, and we can simply press enter to use the default. Up next is the PC over IP registration code. This is something that was mentioned as part of our requirements. Once again, if you don't have a PC over IP registration code, please reach out to our Teradici's sales team using the link provided in the tutorial tab here. Since I already have one, I will paste mine into our console and press enter. The next parameter is our CAS Manager API token. This token is used by the script to create the CAS Manager Deployment Service account. In a new tab, we can type in cas.teradici.com, and then we can log in using a Microsoft 365 Enterprise or a Google Workspace account. I will enter my account credentials and log in. If this is your first time logging into CAS Manager, a pop-up will appear and you will need to read and accept Teradici's end user license agreement. And we'll press Unlock. In the top right corner, we can click on our email address, and then we can click on Get API Token. We can now click on the copy icon, and going back to our Cloud Shell, we will now paste this long string into the command line and press Enter to proceed. The next parameter will be the GCP region. Here it will ask if we want to use the default zone, which is US West 2B. For demonstration purposes, I'm going to enter no, and this will retrieve a GCP regions list. Here we have a number on the left that corresponds to the region on the right that we can deploy in. For example, if we want to deploy in US East 1 instead, we can simply type in 24 and press enter, and the script will now select that region. Since graphics instances are available to us in US West 2, we'll go ahead and stick with the default region, which is option 27. The script will then check for a compute engine quota for that region. Here we can see that we have roughly 6,000 available instances, and we only have one NVIDIA P4 GPU available. After selecting the GCP region, we will also have to select one of the GCP zones. We're going to just pick the first one by typing in 1 and pressing enter, and this will be selecting US West 2A. The script will then check the availability of the graphics VMs in the zone that we've selected. We can see that there's no availability for the P4 VMs, which means we would not be able to deploy any graphics workstations. Let's type no, press enter, and we'll select another zone. We'll have to select 27 once again for US West 2. However, this time we'll type in 2 and press enter. And here we can see that we do have availability to deploy graphics workstations, so this would either be a graphics CentOS or graphics Windows in the zone US West 2B. We can type Y for yes and press enter to proceed. For our last set of parameters, we'll be selecting the number of remote workstations that we want to deploy for each of the workstation types. If we refer back to our tutorial tab on the right and scroll down just a little bit, we can see the various types of workstations available. We will follow the script's prompts and deploy one standard CentOS and one graphics Windows. For example, here we're prompted that we can create up to 250 standard CentOS workstations. Since the default is 0, we can just go ahead and enter 1 and press enter. For the next one, it says we can have up to 1 CentOS graphics. However, keep in mind, since we want to reserve our graphics quota for the graphics Windows machine, we will just press enter to skip, which provides it a default value of 0. Next is the standard Windows workstation, and likewise we'll go ahead and press enter for the default value of 0. It will now prompt us for deploying graphics Windows workstations. Let's type in 1 and press enter. Once our parameters have been entered, you'll be asked to review your selections, and here below on the left we can see that we have a list of the variables and their respective values. And these are the values that we've entered through the command line. We'll also see the number of workstations for each of the 4 types that we'll be deploying, and in this case it will be 1 standard CentOS and 1 graphics Windows workstation. Once we're happy with our selection, we can proceed by typing in yes and pressing enter. The last thing we have to do now is to enter a password for the Active Directory Administrator account. Let's go ahead and enter our password and press enter. It will ask us to confirm the same password. Please note that there is a Windows password complexity requirement as listed in the console here. To begin the actual deployment process, we can press enter, and the script will now deploy our GCP resources using the parameter values we've provided. It will also set up CAS Manager deployment using the API key. The deployment process takes roughly about 20 to 30 minutes to complete, and once that's finished, the Python script will also add the existing workstations to CAS Manager, so this way you as the admin can manage users' access to these workstations. Feel free to pause the video here before proceeding. We've just fast-forwarded the script in this video, and you will know when the deployment is finished when you see the next steps message in the console. If we scroll up, we can review our console messages. You should see a green message that says Apply Complete. This is Terraform informing us that resources have been created in GCP. It will also provide an output right below. In the output, we can see the various IP addresses of the VMs we've just created. Here is one for the connector, an internal IP for our standard CentOS machine, the DC internal IP, our DC public IP, and finally our Windows graphics internal IP address. We can also verify this by heading back over to our GCP tab, clicking on the navigation menu, scroll down to Compute Engine, and over to VM Instances. On this page, we'll see the various VMs that the Quickstart script deployed. The IP addresses here should also match up with what we see from the output in the Quickstart script. Back over in our Cloud Shell, we can also see that the script added our workstations and domain controller to CAS Manager. Under CAS Manager and under our Quickstart deployment, we can see that we have our connector here. If your deployment just finished, the health check may come up as unhealthy. If we just wait a little bit, it should eventually come up as healthy. We can also click on Workstations to see the domain controller and the 2 workstations that we've added to CAS Manager. Back in the Cloud Console, once the administrator user is synced up, the script will also assign the workstations to the user administrator to give it access. Finally, you will see a message here, Quickstart deployment finished, and this is to verify that the entire deployment was successful. And that's it for part 2 of our GCP Quickstart series, where we just showed you how to run our Quickstart script to deploy CAS on GCP easily. Join us for the next part of our Quickstart video series, where we will show you how to connect to our workstations that we've just deployed using a PC over IP soft client.